welcome everyone to the first lecture on probability and statistics. Yeah. In this course, we will be discussing basically this thing, but what I want to talk to you about first is some introductions, a bit about me, and a bit about you, and then a bit about the course, right? And since this is summers, usually I do the introductions and just very basic discussion about probability, and then we stop the lecture. But in summers we have less time, so we'll have a longer lecture, and I will continue with some mathematical formulations. But bit about me. I did my BS here in the same faculty, Engineering Sciences, 2002. I did my Masters. Before that, I worked as an automation engineer, did my Masters in Systems Engineering, did my PhD in Sweden in mathematical statistics. So I know a thing or two about this course. Okay, I have some idea because my PhD is actually in this field. Yeah, right. Thank you. After that, I've been a postdoc there, and then last assignment I had in Sweden was working as a senior researcher at Ericsson. This is the company that holds the most patents and intellectual property rights for 3G, 4G, and now 5G. So at the time we were working on 5G. That was like 4 or 5 years ago. So they still hold the most patents in this, and most of the world's internet, the mobile communications tower देखे ना आप? You see the towers? उनके ऊपर लगे होते हैं radio base station लगे होते हैं RBS. Most of them, the design and the patents are held by Ericsson. So they make most of the money here. So I was part of the team that worked on next generation Wi-Fi and 5G from mathematical modeling perspective. Right? So teams there are bigger. They have all sorts of engineers and researchers. So I was among the guys who handle the mathematical modeling, simulation, and then generating ideas from that, which are later tested in labs. I've also been assistant professor in Saudi Arabia for 2 years. In interest, I like badminton, bowling. I'm not good at either. In Sweden, it was weekend dinners. Now it's, I don't know. Reading, writing. I like to write and read. Not just mathematics, I mean other things also, literature. Roles as a teacher and as a researcher. I have taught full courses in stochastic processes, statistical modeling, probabilistic methods, antenna propagation, and such. I have also given labs and tutorials and supervised, and am supervising postgraduate students. In research, my main field is this: statistical modeling of signals and systems. And my supervisor used to say this is like a hammer, mathematical tool. We go around finding different applications and strike them. Yeah. So the more mathematical your work gets, the wider the application of it. Right. So statistical modeling has application in many fields. These are some that I have worked on: communication with Ericsson, research work as postdoc, and then research work as PhD student. One of my research projects, why I am mentioning this is towards the end of the course, I will connect some parts of this to what you have learned in this course. Yeah. So you don't feel that this is just to complete your credit hours. Okay. These things are going to be very useful to you in most of the work that you do. So it's good to have basic understanding of this. So one of the research projects I worked on was funded by World Health Organization and Wellcome Trust. Welcome, Lec1 welcome का सुना आपने? Medicine होती है, right? Pharmaceutical है, पाकिस्तान में भी sell करते हैं काफी. They were also funding it, and the question was how to quickly tell whether a medicine is fake. This was needed in some countries where the issue of fake medicines was too much prevalent. Okay, so people were getting funds from other countries and then just embezzling those funds and selling or giving fake medicine to the masses. Yeah. So these guys wanted to develop a way to scan the medicine in the pharmacy or at the customs. पहले क्या होता है और अभी भी mostly what happens is that the officer will go to a lab, to a pharmacy, wait, छापा इसको कहते हैं, छापा मारते हैं, क्या करते हैं? They collect samples, they bring those samples to the lab. The lab technician, whoever, mixes it with some solutions, puts it in a machine, and then tells. By the time they find out that the medicine is fake, पीछे वो पूरे डब्बे change कर चुके होते हैं. Right? So you want to catch them on the spot. So this research was to find a way to develop a handheld briefcase type, and we built a prototype with the help of an Italian team. The chemists working with us were from King's College London, and we were the mathematicians doing the mathematical modeling, simulation, analysis, and then a team of electronic engineers in Italy. Then they built that equipment. So we were a consortium, a team of researchers working together.
I have a question.
Yeah, go ahead.
Sir, if the medicine is the same formula but it has a different name, would that be considered fake or original? Like if you go for paracetamol, there are a lot of medicines.
So when you say paracetamol, you are talking about the active ingredient.
Yes.
The active ingredient is paracetamol. Yes? It can come with another name, another brand, but what we want to see is that if this medicine claims that the active ingredient is paracetamol, then that should be there. Fake में क्या होता है? चीनी डाली हुई, right? Or something else, yeah. But paracetamol will either not be there or would be there in a very low concentration, right? So very good question. Yes, you have to identify what you do. So the method we used was a relative of NMR. Do any of you know MRI? पता है क्या होता है? Magnetic resonance imaging. किस लिए यूज होता है?
Internal
Different scanning, right? So kind of let's say advanced X-ray, right? It's like we do. So what do you need in a magnetic resonance imaging? Basically, magnetic resonance imaging is an application of a physical phenomenon known as NMR, nuclear magnetic resonance. Yeah. So what you do in NMR, basically, I can press this. Let's see. You take the chemical that you want to scan, or the person or the thing, yeah, and you apply a very strong magnetic field to it. Okay? That magnetic field distorts the nuclei in the molecule, and they behave like small magnets. Okay, that's where the magnetic thing also comes from. And then you throw a radio frequency at them. You throw a radio frequency at them, and you collect the response. Okay? And the response is a resonance. Resonance पढ़िए, किस context में पढ़िए? Physics में पढ़िए, right? Different phenomena you see in the resonance phenomena there. So that is something happening here. It resonates in response. But the resonation frequencies, the resonant frequencies are a function of the chemical composition of the atoms there. वो किसके अंदर है उसके लिहाज से उसकी resonant frequency changes. You have seen that before. कहाँ पे strings have resonant frequency? Yes. If you tie it up with the edges, it has one resonant frequency, set of resonant. If you tie it in the middle also, the set of resonant frequency changes. So the resonant frequencies can give you an idea of the physical constraints of the string, right? Something similar to that is happening here. The resonant frequencies are actually a function of how the molecule and the atom is locked in a compound. Okay, so to cut this story short, it's what's the magnetic field doing there? It's helping distort it. This is much like you go to a studio. In old days, these days go up to the but they used to have very strong flash. क्यों होती थी वो? एक light होती थी, right? Spotlight light. Why did we need that? Picture clear आती. Yes, very bright but clear pictures clear आते. So the magnetic field is actually playing the role of these guys, helping you make this image clearer. Once you get the image, clear image, you can tell. Go at them. He's the Einstein of mathematics, Hilbert, right? One of the most influential mathematicians in Hilbert. Okay. So anyway, these two guys you can identify. Similarly, if you apply this light, this magnetic field on this, you get resonant frequency, and then every chemical compound has its own unique frequency pattern, and that pattern you can try to find. Paracetamol will have one pattern, right? And if it is the active and the most dominant ingredient in that medicine, I should get a very strong profile matching the paracetamol. Yeah. So, what's the problem with this? Can anybody tell me what's the problem with MRI?
पेनिट्रेट करती है आपके बॉडी के अंदर, वो डैमेज भी कर सकती है।
डैमेज करती है। उसमें क्या चीज पेनिट्रेट करती है? कौन सी चीज है? वेव है। Which one?
रेडियोएक्टिव वेव।
नहीं, रेडियोएक्टिव उसमें नहीं आता। But yeah, good. It's not this scan जो वो करता है ना, उसमें कोई मसला नहीं. That's just radio frequency. It's this guy, the very strong magnetic field. That is dangerous. उसका जो डोज है बहुत हाई है जिसके अंदर हाँ उस मशीन में जो मैग्नेटिक कॉइल होती है, the magnetic field is the problem. But without the magnetic field, what happens? The picture gets blurry or not very clear. मुश्किल हो जाएगा बताना. Okay, you could tell these guys apart, but कोई इससे मिलते जुलती शक्ल का हो तो it will become harder to tell, harder to resolve, right? So, okay, I have this pointer, so I think I have to close it. Yeah. So in NQR, nuclear quadrupole resonance, you don't use the magnetic field. So there are many nuclei that are naturally quadrupolar, that is naturally elongated, so they have 4 poles. So they behave like tiny magnets naturally. The problem with that natural thing is, without the magnetic field, the picture you get, this small lines, can you see the small line inside? That is the, find a way to do that, yeah. So, this small line inside is the signal of interest and the rest is noise. So, the signal gets very weak. So weak that it reaches, like the noise can be 10,000 times stronger than the signal. The magnetic field helps you make this signal, the inside one, larger and you can easily see. But without this, how do you now try to, what's the benefit here? No magnetic field. You don't need that expensive big magnetic field, it's not dangerous to have. Without the magnetic field, you don't need to carry that big machine to a pharmacy. Yes? What's the problem? Problem is that the signal is too weak and there is lots of noise entering. So that's where mathematical statistics, mathematical modeling comes in. If you can smartly try to find statistical properties of the signals of interest, you can still estimate or find if that signal is in there or not. That's called hypothesis testing. Hypothesis null is signal is there. One signal is not there. We will see this in the course later. But that was what we worked on. We were able to get signatures from different chemicals, and we were able to model these things mathematically and were able to show that you can still, with reasonable accuracy, show that you can with reasonable accuracy find the active ingredient. Okay, so I will come back to this later when we talk about uncertainties from one reading to another, why are there variations, all of that. Yeah, and you will see some of that in this course also. About you guys, we already had a meeting, so we can skip that, but I understand some of you are here for originally for 202. Yes, 202 are here. So, few. Mostly 111. Yes? Okay. So, whatever the reason and whatever brought you here, we can try to make this course very interesting and try to learn from it. Now the course, and I guess you are from different faculties. Yes, सारे program पढ़ते हैं.
Different batches.
That is all as well. काफी varied किस्म का combination है. But this course is very independent of almost everything, so you don't need background in almost anything. Some basic math which you have already done, so it's not an issue. Right, the course. So let's see. I will talk about these four things briefly. Firstly, why study probability? How is the content organized in this course? Where can I apply what I learn? What is the course conduct? How is the course conducted and assessed? Yeah, I will email you or WhatsApp your CR. Oh, I'm WhatsApp कर दूँगा आपको outline. Yeah, it's ready. Email मैंने करी थी लेकिन मुझे भूल गया. So I'll send you that. You will know how the course is conducted and assessed. But for the rest of this, we can talk a little bit. Okay, so why study probability? And we will talk about this later also. There is a very short answer, but we will elaborate on that later. It's basically wherever you would like to use or you can benefit from including uncertainty, variation in your mathematical model. Okay? You have worked with mathematical models and mathematics without uncertainty already, right? So if I tell you that x plus y equals 7 and y is 3, you have done that before, right? You can find x, basic algebra, then you took that to nonlinear equations. You did that. Quadratic y is equal to ax squared plus b. I tell you a and b and x, you can find y, or if I tell you y, a and b, you can find x. Kiya one? There was no uncertainty there. Yes? Now what we want to do is we say x plus y equals 7, but you know y is like, maybe it is 3, maybe it is 4. Okay, so what are the chances then? It is 50% of the time it is 3, 50% of the time it is 4. Now what is x? Yeah, how do you work with that? Why is there uncertainty in the first place? That we will of course discuss. But the key idea here is to take the mathematics that you have learned so far, which never included uncertainties, unknown bhi jo tha, if one value was unknown, it wasn't varying from time to time. Yeah? But now things will have uncertainties in them. Why they will have, we will see. But how is the content of this course organized? So basically, I will close this presentation mode. It's my first time using this. So, why do we want to, or what do we want to cover in this course, or how will we cover it? Yeah. So suppose I record your voice towards the end of the course. One of you is recorded saying this. आप लोगों को मुझसे ज़्यादा एक्सपीरियंस है. Right. So have you ever used a voice recorder on your mobile or something? Yeah. When you record, वो wave pattern आ रहा होता है. Let's say I record one of you saying something like this, and you say it 3 times. Yeah. The same thing. And let's say this is hopefully not, but let's say you are saying this, yeah, and you hate it so much that you say it 3 times. I hate this course, I hate this course, I hate it. And we record your voice. Do you think the voice patterns and the signal we record at every given point in the 3 utterances, would it be exactly the same? Or will there be variations? Variations only? Okay. So from one utterance to another, there are expected क्यों आएंगी? कोई वजह? Noise could vary, right? What else? Yes. So किसी दफा तक आपको गला थोड़ा बैठना शुरू हो गया next week. That same person, but voice थोड़ी सी hoarse हो गई है. So what happens then? So there are variations from one to the other, but despite the variations, there is something common in here, right? You can still extract information from this. What is the information? What can you extract? It doesn't change. It doesn't become I love this course, right? You know what? What is fixed is you hate the course. Right? Fix that. What else? क्या और fixed information extract? Despite the variations, despite the uncertainties from one utterance to the other, you can still find some common information in there. एक कहा क्या गया? As long as you know the language, yeah. And now this is translate. What else? क्या है? Okay. Something. Yeah. कितनी देर का? What else?
हर वर्ड के नोट्स भी अलग होते हैं, वो भी एक तरह का मैच करेगा कुछ जगह पे.
Okay. So can you also, most cases your ear can tell that this was the same person. Yes. ये भी तो common information निकाल लेते हैं despite the variations. What else? In most cases you can tell it's a female or a male, right? Adult or a child. In most cases there are of course exceptions. We'll see that later. So from here, let's see how we are going to organize this course. Yeah. Firstly, we may be interested in seeing, okay, how are these variations? The variation from one utterance to the other. How can we talk about these variations mathematically? Okay. So as I gave you the example of x plus y equals 7, before this you were saying, oh yeah, give me y, I'll give you x. Now I'm going to know y has variation. Sometimes it's 3.5, sometimes it's 3.6. Now find y or find x. Yes? So first thing we want to do, okay, let's try to ये पूरा कैसे क्लियर होता है?
इरेजर के ऊपर दबाएं, क्लियर ऑल का ऑप्शन भी आएगा उधर नीचे ऑप्शन में.
हाँ.
एक बार दबाएं सर, क्लियर ऑल.
Okay, so first thing we want to do is talk about uncertainty mathematically. Okay, how to represent uncertainties mathematically. That's the first thing we want to do. Yeah? How do we use mathematics to write these answers? Yeah, and I have to learn to make bigger boxes. Okay, say कितने लिखा रहता है? बारिश नहीं दिख रही. Okay.
कर सकते हैं इसकी भी वो.
है इसकी भी है.
Yes sir. पेन के ऊपर दबाएं. उधर जो पेन
ये पेन चेक कर लें
वो ऐसे साइज थोड़ा कर दें, माइनस कर दें. बहुत माइनस कर दें.
Good. So let's clear this. We are training भी चल रही साथ साथ. Okay. So how can we write those variations in the voice, right? Those variations, how can we show them mathematically or represent them mathematically? That is module 1 of this course. We will talk about the mathematics of uncertainties, just to get it started. Yeah? Okay. Next, we may be interested in saying, okay, we have talked about how to write the uncertainties mathematically, but now how can we collect that information in, let's say, efficient models or formulas, right? So for example, you already have done that in the regular method. Yeah, circles and many circles and many circles, you have a formula for that. क्या होता है?
2 pi r square.
वो तो उसका रेडियस वगैरह होगा, right? So any given point there satisfies a square plus b square equals r square, right? So you have efficiently written that formulation. So we also want to collect these uncertainties in some mathematical formulas or models. Okay. So what we will do is,
ये भी हो सकता है कि 2 pi उसका होगा रेडियस तो फिर वो बल्कि सेकंड पॉइंट होता वो सर्कल होगा. एंगल उसका होगा 360 डिग्री का.
yes, you can model in different ways. Yes. So in this case, what we want to do is write, okay, how do we collect information about uncertainties. So this will be our second module. Okay. On what kind of functions? Basically, there will be distribution functions, density functions. Where can we collect this information about uncertainties? After that, we will be interested in seeing, okay, this information we will find is actually too much. So we will try to extract useful parameters from this information. Okay, to summarize this information, and that we will do here. Extract useful, or actually I should say key information, because it's all useful. So because we will find that this will be, in most cases it will be TMI. What is TMI? Generation Z to too much information. Yeah. So you will realize when you collect these uncertainties, this will be TMI. The functions you will get, both are the information of this. Very hard to work with. So what we will do is, okay, let's extract some parameters, some information that we can work with practically. Yeah. And that we call extracting key information. And this will be our third module. It will be about moments. Yeah, mean, variance, covariance, those things you extract from the distributions. Then we would be interested in saying, okay, all of this that we have done so far is theoretical. First we will do it theoretically. Yeah? But then we realize in real life you don't really have all the data available. Yeah? The real life is different. Yeah? So in that case, we will have to see, okay, we will have to get real. This will be our third module, fourth module, get real. So from theoretical to real data. Now I have just collected data. I don't have the full knowledge of the problem. I only have observed a sample of the problem. Yeah. Now, how can I extract the information? Theoretically, it would have been possible using the methods learned up to here. But in practice, you will not have all the information that the theory requires, so you'll have to work with real data. Yeah, and this is the what we call sampling statistics, or talking about statistics of a process or data based on an observed sample of this. Yeah? So like for example, the example of the voice note. In an ideal world, you should know, the theory will say, yeah, give me all the possible ways this person can say, I hate this course. Give me all the possible noise values, and I will give you some information. But that's not possible. So we will have to work with maybe 3 samples only. Now, from those 3 samples, how do we extract the information? The 5th and last module of this course will be, now we want to see, okay, how can we efficiently model a random or an uncertain process so that we can write an equation for it and also predict its future values. For example, जब आप line की equation लिखते हैं, क्या लिखते हैं? What's the equation of a line? mx plus c. Yeah. Once you have found m and c, I give you any x, you can find the y. Yes. So basically, you are using how many points you need to do that? By the way, 2 points. Yes. So you use 2 points to find mx, m, and c, and then what you can do? What's the benefit of that? Now I can get y for any x, right? So I can go over here or here, extrapolate. Yes. If it was missing in the middle, I can interpolate all that. So this in a way is what you are predicting what's going to happen to this thing afterwards. You were already doing that, but you were doing it in the certain mathematics. There was no uncertainty involved. Yeah. So in this case, we want to do model and predict. So I want to write a model for my voice. आप देखते हैं कंप्यूटर जब जनरेट करते हैं ह्यूमन वॉइस कैसे करते हैं? सारी रिकॉर्ड करें कैसे करते हैं? ह्यूमन वॉइस करते हैं sample set. So what do you mean by sample set? Like somebody has actually said all those things there. मॉडल ट्रेन किया हुआ। इन ओल्ड टाइम्स ऐसे ही था, किसी ने सारे लफ्ज बोले हुए फिर उनको जोड़ देते हैं तो उतनी अजीब सी आवाज आती है। क्या आजकल तो they are very advanced, they are actually generating on the go, right? So they have some, just like you have M and C, and now you can generate anything you want. Yeah, they have for this kind of things where there are variations, they have made a very efficient model. Yeah, ये जो आपका AI, ChatGPT क्या है? Models हैं. Yeah, कितने parameters हैं GPT-3 के? Billions नहीं, right. इस पे मैं यही कहूँगा sure. लेकिन वो बाद में. For now, that you must have read about it. Trillions हैं कुछ के parameters. Those parameters are recording these models. So this is where modeling and prediction comes. Now just to motivate you further, remember this, that this course, what you learned here, is also going to be the foundation of AI, machine learning, all that. वो सब इसी की extension है. Okay, you can be a coder, you can give a mathematics, Python खोलें उसको कहें जी ये data है इसको predict करो. Yes, but you cannot interpret or analyze properly without these tools. पूरा वो इसी के ऊपर built है और actually this is जो AI and machine learning is actually this part. Of course इस course में हम उधर तक पूरा नहीं जाएंगे, but you will see a very early machine learning algorithm, the linear regressor. Okay, so it will already start from it. So if you really pay attention to this course, and you may be thinking, okay, I'm not in computer science, but nobody can escape. आज के दौर में कोई engineer computer को escape कर सकता है, use करना पड़ता है. It's the same thing now with machine learning and AI. It's a tool. Okay, you cannot escape as a calculator. Computer को escape करेंगे, computer में जाएंगे, refrigerator में calculator. So you cannot escape machine learning and AI now. वो एक tool है, हर एक में use करना. Yeah, so better get a good understanding of it, even if you're not going to study that further yourself, but you will be using it, and to be a smart user, to be able to improve it, tune it properly. ठीक है ना, अंदर tune करना Python में variable change करते जाए, try करते जाए. They can really knowing what's happening. What can I do to fix it smartly? So getting to that very quickly. That is where you will need this course. Okay. So let's see. Five modules in the course, okay? And if you understand these 5 aspects, you are good for a lot of other courses and a lot of other topics. I want to find a way to get out of this thing. Minimize, yes, good. So over here. So this is what I just answered for you. How is the content organized in 5 modules? Okay, you don't have to memorize the modules now. I will come back to them, of course. So that is what the course is. Where can I apply what I learned? Essentially, if you want to use it, you can use it everywhere. But I've already mentioned AI, machine learning should already be a very good thing for you. And believe me, it's it's data analytics in finance, in biology, in logistics, in facility planning, in mechanical engineering. When will the component fail? What's the chance? Probabilistic है, कोई fuse हो जाता है, इसमें भी हो जाता है. Yes. So how do you work with that? How do you plan for your machine to be operating 24 hours a day? How many spares do you need? Cost क्या होगा? All those things, a lot of prediction, yeah, is based on what you learn in this course. So where can I apply this? What I learned? Those of you double channel. Yes. Okay. Communications, Greenfield, yeah, 5G, all that. I used it in communication in Ericsson. So these signals that are transmitted between your mobile and the base station and your friend, from the aeroplane to the satellite to ground station, all those have random variations. Yeah. Without this knowledge, you cannot effectively or efficiently resolve the unknown parts from the required parts, or the unwanted parts from the wanted parts. Okay. So it's there in communications. It's there in biomedicine. You know EEG?
So waves are people.
Right? There's ECG, electrocardiogram. Brain calls that EEG. One of the research publications I did last year, we were trying to use these models, apply them to the cases of from the EEG. You want to identify if a person is going to have a neurological disorder soon or not. Okay? But from this data, you can tell if the heartbeat has some arrhythmia in there, or their brain. Epilepsy का बताओ. Epilepsy maybe. Yes. You know, you can already, if you apply very basic mathematics and reading to epileptic and normal reading of the brain before the epilepsy. During the epilepsy, the readings go crazy. Anybody can tell. They can be take a dora for it. Yes, they're having a fit. But can you tell before it happens? Yeah? Where if you have a good understanding of the statistical modeling of the human brain signals, you can actually predict much in advance that a fit is coming. And if there is a person in intensive care, you can save their life by raising an alarm, automated alarm. Yeah? Finance, huge. Finance में कहाँ आएगा? क्या चीज़ आंसर है? Finance में? Stocks कितने आंसर है? हाई आंसर है. Lights बनती है तब हो जाती है फिर बनती है. मुल्क बनते हैं तब हो जाते हैं. Yes, financial. Now you may be saying, okay, if you are saying we can predict things or work with this, then why don't we all make money? No, through nothing. Why is that? All the methods you are going to learn are not going to make you prophets or omniscient. God नहीं बने. उसमें there will always be a margin of error. Okay. The more uncertain the original system, the more margin of error there will be. Okay. उसकी वजह से क्या होगा? You will have chances of not predicting things properly. Yeah? Should that stop us? Banks चल रहे हैं. वो आपके पैसे लेके invest करते हैं. कहाँ invest करते हैं? Where their models tell them that the likelihood of getting good results, good payoffs is high, right? So they are still working. कोई बैंक जो है वो कोई close होता है. So in reasonable span of time for 6 months, year, you can predict many of your investments or things like that. Yeah. So definitely finance, and again, I won't mention it again and again, but AI is now doing all that. Yes, and AI is based on what I showed you before. You need other topics also. You need AI, and this is one of the core things. Okay, so finance is there. Chemistry की example मैंने already आपको दे दी from my own project. Remember, medicine, paracetamol, that thing. So that was chemistry. Trying to this guy is trying to find a landmine, or I don't know if it's an undetonated bomb. This is a good friend trying to give him a mini heart attack. Yes, so chemistry, yes, you can try to find if there is an active compound or not, or you could just use probability to prove the existence of activity. You know this guy? Yes? Now, some of his papers are very well known. For example, these two. Among you, right? ये क्या है? Photoelectric effect. पढ़ा था? Yes? बैठा लगाना पड़ा है. Threshold होता है. Yes? Okay. Everybody knows about this. Special relativity. क्या है formula? E equals MC square. But in that very same day, this guy wrote another paper that finally proved the existence of atom. There were guesses: is it an individual particle or not? ये तो components तो नजर आ रहे थे. There are nuclei, there are electrons, but it wasn't. There was still a debate: are they individual particles or not? कोई combined wave है, कोई string है, क्या है? Are they individual particles or not? Brownian motion पढ़ा क्या होती है Brownian motion? Pollen grain. Robert Brown, 200 years ago, before this guy, or 100 years before this guy, क्या किया था उसने? He dropped pollen grains in liquids and observed them with some microscope, and he was drawing their motion. क्या उसने नजर आया था? ऐसे लग रहा है उसको कोई अंदर से टकराई मारा है. यही हो रहा था. But he didn't know what's going on. Einstein used theory of probability to mathematically describe that motion. Okay, and in so doing, what he used, उसकी जो assumption थी, वे थी कि these have to be individual particles which are moving randomly. Individual particles which are moving randomly, only then can you properly explain the Brownian motion. Okay, so that was a definitive proof of the. अब तो है स्कैनिंग इलेक्ट्रॉन माइक्रोस्कोप से आगे क्वांटम माइक्रोस्कोप में इंडिविजुअल एटम की इमेजेस को ग्राफ आ जाता है. So what I want to show you by this is that the possibilities are infinite. It's up to you how you want to use this, right? Einstein used probability to prove one of the most fundamental things in nature. Yeah, you can use it in other ways that you like. For this, you can I will send you the outline. Then see that, and we can discuss it briefly maybe next time. The outline. Let us see. So we will take a short pause here for 5 minutes, and then I will continue with the description of the course itself, probability and statistics. If you want to discuss anything, 5-minute break. I don't know, cooling ये वो बिजली गई है इस गई है. Hopefully it won't be like this all the time, but what's the time now? By my watch is 4:20. If you want to take 5 minutes here or there, you can, and 25 we will start again. Okay? Okay? Meanwhile, आप में से किसी को, if you have any questions about what we have discussed, अभी तो हमारा general discussion है, of course we will come back to these topics again. But if you don't want a break, I can continue. Continue. जल्दी खत्म करेंगे. Okay. Right. So usually this is where the first lecture would end. But let's go to the second set, and for that I will have to exit this thing. कहाँ से होगा? They must have copied it somewhere. Documents. Recent the desktop thing. Okay, so let's start with our basic topic here. Title में क्या है course के? Probability and statistics. So what is probability? कोई बता सकते हैं? Chance of something happening. Okay. Chance of occurrence. Chances of occurrence. Okay. और कोई definition? Likelihood, chance, good for. I like to think, you're right, that is, of course, that is also probability. I like to think that it is the lack of knowledge that leads to probability. Probability is lack of knowledge. Why is that? Let's say I ask one of you your heights. Yeah? पता है अपनी height को पता होती है? Will you say it's probably 5-7 or exact बताएंगे आप? बताओ. So your own height, you know. So you won't say it's probably this much, right? In most cases, I know I'm 5'10". So probability comes in. You say probably when you're not sure, right? There is lack of knowledge. Yeah. So okay, why do we lack knowledge sometimes? Any idea?
Measure of accuracy.
Measure of accuracy, yeah, accuracy can also lead to uncertainty. So that's one thing. What else? Why do we lack knowledge sometimes?
Accurate knowledge तो नहीं होता सर.
Okay, so we have only finite knowledge. So let's say, are you here in this lecture?
Yes.
Yes. No probability. Probably here. No, you are. Will you be here in the next lecture? Probably not. Oh, yes, you decide. Yeah, but क्या हुआ? Lack of knowledge आ गया. You have to add probability there. Probably I will be here. Yes. So why is there lack of knowledge in this thing? Future. It hasn't happened yet, right? So that's one reason. Why else will there be uncertainty? Someone here said the issue of accuracy. It might be that the effort required to collect all the information is too high. Okay, so you could, for example, if you're working with a system, if you could measure what every atom was doing at different times and all that, you could try to predict, okay, what's going to happen next. Yeah, but what is it? It's too hard to collect. In many situations, the full information is too hard to collect. Any other reason you can think of? So, as I already mentioned, this is future event. Why do we sometimes lack knowledge? Hasn't happened. I haven't thrown a dice. This is a dice, yes. I haven't shown it yet. What will it show? You cannot tell. It's a future event. What's the height of the next person that enters this room? I cannot tell. Now in that case, what happens is, I could, for example, even in the first case actually, if you can measure exactly with how much force this is thrown, what's the air pressure, what's the surface like, if you can write all the physics of that, you can actually tell if it will be heads or tails, given the right initial conditions. But what's the problem with that? It's just too hard. Yeah. So in many situations, it's too hard. Height of the next person entering the room. Yes, hard for me to tell. But what if I could have a drone following each of you? Everyone in the world has a drone, very small drone behind them. Then I can already, let's say, I have a system where I can see who is coming in. Yes, the drone. Yeah. So from the chip, my mobile tells me that person X of height so much is about to enter. I can do that. But what's the problem with that? Too hard to collect all that information. So lack of knowledge sometimes comes because it's future, sometimes it's because it's too hard. There is a third reason for lack of knowledge. It is more philosophical. So let's see. You know quantum physics? Yes? You know it, yeah? So now, okay. According to quantum physics, there are certain parameters that are by very nature uncertain. Heisenberg uncertainty discussed about. Yes, what does it say? Now, if you find the momentum of an electron or a small particle exactly, then you will always have uncertainty in its position. And if you find its position exactly, you will always have uncertainty in its momentum. Yes? So, what's he saying? Basically, the current interpretation of quantum physics says that nature at its very smallest level is probabilistic. Okay, so that is the quantum weirdness. You cannot, there are certain things that you cannot know exactly. आपको पहले electrons को पढ़ाते थे कि वो orbit में है, फिर पढ़ाते हैं shell है. Yeah, now they say it's a probability cloud. Schrodinger wave equation. देखिए, yeah. So there are uncertainties in there also. Okay, so this we have discussed. Why steady probability? I have already mentioned. Height of the next student who enters the room. Yeah, I don't know. But is it that we know nothing about the height of the next student by the way?
Average height से कर सकते हैं.
Average height कर सकते हैं, right? So you have some idea. Yeah? That means our lack of knowledge is not absolute. Yeah? Probability is lack of knowledge. But then we realize, okay, in many cases our lack of knowledge is not absolute. Do I know something about the height of the next person coming in? Who's the shortest person in the world right now? क्या height है उसकी? Very less, बहुत कम chance है कि the next person coming in shorter than that, right? Who's the tallest person in the world? The chances that the next person coming in taller than that are very low. So we have some range for human heights, right? That information is statistics, right? Probability is lack of knowledge, but when our lack of knowledge is not absolute, we can use statistics to still make some decisions. You know, statistics have been used in this room to make some decisions already. Okay? Can you see something? Height setting. You can use that information to design things. That has already been used. See the reason? Yes? Why isn't it this height? Design is already here. Average human can easily pass through it. Benches be. A lot of design here that relies on statistical information, right? So, yes, we were shortest taller some years ago. I don't know if they still there or somebody else was selected. But the next person coming in is most likely in between. And if I know it's a male or a female, we can also have separate distribution. But look, those are not designed that way. Yeah, if they were for animals, yeah. But for humans, now why can't we make it even bigger?
क्योंकि हम giants नहीं हैं.
Giants नहीं है and that's debatable. Giants नहीं है. अच्छा, बड़ा क्यों बना?
क्योंकि वो inconvenient रहेगा.
Useless होगा सर.
Inefficient हो. Inconvenient भी होगा उसको कुछ करना. But it's inefficient. You're wasting wood, aren't you? You're wasting this space. So you already have that design element in here. So basically, when we lack knowledge, lack probability, the lack of knowledge is not absolute. We do know something about that thing. Height of the next person, I don't know, but I know its distribution. Very few people, very short. Very few people, very tall. Most of them in between. Yes, दुनिया में इंसानों की हाइट का भी एवरेज होगा. पाकिस्तान में मेल्स की I think 5'7" है. स्वीडन में मेल्स की 5'10" थी. So in Sweden I was average height in men. Most were by that I mean around half were either my height or taller. Pakistan में I am a bit taller than the average. So you can decide and design and make smart guesses based on whatever statistics you have. Yeah? So this is what gives us hope. अगर हम ये कह देंगे कि we lack knowledge, नहीं पता what driver is. Okay, so then we just stop it. Yeah? But in most situations, what you can do is use this information to make good guesses. Okay. आप लोगों ने स्लाइड्स पढ़े? क्या आपने साइड?
Group option. Group करके हम लोग ऐसे.
Collection of objects, things. Yeah, it's a collection basically. Yes. So a set of possibilities. The sentence I written here to motivate the main topic. The probability price that here, the mostly we start with sets. Why is that? Because they go hand in hand. Okay? Set of possibilities is that you try to identify, okay, what is possible. So if I throw a dice, I don't know what its outcome will be. Yes? I have knowledge it. Yeah? But can it be 7? Normal dice will be हो सकता है. 1 to 6 ही होगा. 1.5 भी नहीं हो सकता. 0 भी नहीं हो सकता. Yes? So we will quickly review sets. Why? Because sets and probability go hand in hand. When you roll a die, you can write set of possible outcomes and set of impossible. Everything else is impossible. Yeah. So when you try to write the set of possibilities, right? इसका नाम पता है आपको set के अभी नहीं क्या है? Right. So this is called FSC में होती है skip करें. Taylor's होती है. Okay. तो इसको क्या कहते हैं? जो a set that contains all the possible outcomes of sample space. Yes, sample space. Yes. So the set of possible outcomes, you have it here, is 1, 2, 3, 4, 5, 6. We call it universal set or sample space. So they go hand in hand. I will quickly review. What is a set? It's a collection of objects, as you said, or things or entities. Every entity in here is called an element, right? And the notation is when something is in the set, it's E, element of. Yeah, A is a member of capital belongs to, and E is not. Yes, so you know this. I will go through this very fast. Let's say I am teaching 2 courses, and I have students. I have drawn 3 sets here. Yes, what is set A? Let's say in summer I am teaching these 2 courses. Okay, and what is set A? All of my students in this summer. Yes. Okay. What is set B?
The student can 3
Yes, and students in EE 3 to 8. And what's this?
both of them.
Which are in both of them. Okay. What about the red ones? Only red ones?
Which are only in E 3 to 8.
Only in 3 to 8 and not in 3 to 2, right? And the yellow ones only in 3 to 2 and yes? And what about everyone else? A prime. Yes? A complement. Boolean algebra A complement. Yeah? So, yes, you have already answered this. B is my students here, C is this. B union C is my students who are in CO2 or this one. What does that represent here? It's A, basically, yes. Intersection क्या होता है? When they are in mutually overlap, common, yes. Minus क्या होता है? When they are in one set but not in the other, yes. So this A minus B or B minus C, you can write it B minus C. You can see is actually only these guys. C took away part of the B also. So उसने एक white ले लिया, yeah? जो common थे उसने निकाल लिया. So you know these things. So I won't go in detail. ये you know about a subset. Yeah, a subset is when a set falls inside another set. Right? So I am saying this set D. Students who are taking both 302 and 328 in B. Both sides set. Let's call that D. So D is a subset of. Is it a subset of B or not? It is. It is a subset of C. It is within that. It is also a subset of A. So that's the thing. You have commutative property. Union is commutative. Intersection is commutative. Yeah. Addition is commutative. क्या नहीं है commutative? Subtraction, multiplication is commutative. Division is not. Yeah. इसी तरह यहाँ पे union and intersection are commutative. Subtraction that is listed is not commutative. Then there can be sets that are empty. Okay, that have no members in them. Okay, so you can see. Sometimes we like to draw Venn diagram. I'm going past through the sets for both the basics. You can review them in the book also. It's fine. Union is take them both, yeah, without repeating the common parts. Just take them one time. Yeah. Intersection is take only the common part. Difference is if it is A minus B, then take A and remove from A whatever is there in B also. Right? So this whereas only this part is there. Okay, so there is empty set, then there are mutually exclusive sets. Okay. So what is a mutually exclusive sets? Sets that have no common members. Okay, that is mutually exclusive. In almost always, basically always, students who are here and who are not here are mutually exclusive, right? So they cannot be in both sets. Universal set we have already mentioned is the all-encompassing set, the theoretical set. Complement of a set is S minus A. You subtract the set from the universal set. In some cases it's imagined. In probability theory the universal set is actually the sample space. Yes, the set of all possibilities. Okay. So two sets are equal if A is a subset of B and B is a subset. That's one way of proving it. Another way is to see that okay, if they are exactly element wise they are equal, they have the same elements, then they are equal sets, set operations here. So you have set A is here, A complement, if they are disjoint, there is no overlapping part. If B is a proper subset of A, the whole of B is inside A, yeah, is covered by A. Okay, so we will skip some part here. Notation. So some notation. Do you know summation, sigma notation? Yeah, please. So if you are doing x1 plus x2 plus x3 so on, what do? You have sigma xn, you need to have summation xi I is 1 to n. Yes. So similarly we have notation for union of sets and intersection of sets. Okay, and this is the notation. Just like to make it more efficient, you write it as summation xi. Here you can write it as a big U. Okay, that is what you're saying. If you expand it just like this guy, you expand it, you say union of A1, A2, A3, all of those. Union of those. Yeah. Similarly, if I want intersection of n sets, I can simply show it like this. Okay, it's just a quick note on notation. Again, I'm going a bit fast through the sets because you already know those.
ये जो नोटेशन लिखते हैं इसमें जो एक्सेप्शन लेंगे, अगर इंटरसेक्शन में एक्सेप्शन है, मतलब अगर से 3, 4, 5 इंटरसेक्शन की वजह से निकल गया तो वो किस तरह रिप्रेजेंट करेंगे?
3, 4, 5 are not in here.
No, they are excluded because they are not common entities.
Right. So in that case, if your this notation इसमें क्या करेंगे? If x3, 4, 5 are not here, you can write like this. So what's the reason?
वो तो ये करेंगे ना कि 1, 2 and 3 do not belong to set.
Yeah. No, currently we are not making the set. We just talk about the notation, right? So here you will say I is 1 to 2, Yes, and then you say 3 is 6 to n. We will drop those from the notation. Right? That's one way. Another way is to put a minus here and remove that. Right? Summation I1 3 to 5. You can subtract that. So essentially, this is helpful mostly when you have a lot of unions going on. Right? We're not doing the actual operation in this. Yeah? So just showing how to efficiently write this here. Okay. So I've already mentioned commutative. Then there is associative and distributive. Nothing else is plus or multiplication key associative and distributive properties. It says that A intersection B union C is the same as A intersection B union A intersection C. You know these associative, distributive, or plus, minus, multiply, divide, you know that, right? So here you have those for multiple sets. Morgan's law. Now that yeah. Basically it says that A union B complement. What does that mean? A union B complement.
All the entries except for which are in A.
So complement always assume that you are subtracting from the universal set. So it says S minus A union B.
S represent होता है inverse से.
In this probability के most portion, right? Sometimes we have this capital omega, and I think for you this is enough for the size. So it's saying S minus A union B is the same as what?
A intersection. A complement intersection.
Yeah, it's the same as S minus A intersection S minus B. Right? So this
बाद में की होगी तो मतलब इसको complement किया ना.
ये complement के there are two symbols often used, A prime or A bar. Okay, so we can check what your book is using. We are in the exam etc. We stick to
Prime
that.
ही होता है.
Right?
Prime ही होता है.
Prime will be clear. We will stick to that. They are also fine. So then you will have A union B prime here. Yeah, that is A prime intersection. So this changes, and that is the De Morgan's law. I don't need to prove it. You can see the Venn diagram to see and read in the book also if you want. This. So duality principle, I can leave it as a reading exercise. Okay, you can see that in your book. Any questions so far? ये तो आप बताओ. What one mutually exclusive sets? That have no common elements, right? तो उनमें कुछ भी common नहीं होता. That was basically ये थोड़ा सा different था. Otherwise there is nothing special here in that. So I'll get something started, but we won't finish it today. We will come back to that next time, and that is now using sets to assign problems. Okay, so let's do that quickly. I won't start that. How do we actually define problems? So today I'll just get you started and we'll come back to this in more detail. In the very simplest approach and the most commonly used approach, this is how it happens. What is the probability of a random event A? I will define it. Yeah? We will come back to this formula. It's the number of ways A can occur divided by total number of outcomes. Now what do we mean by that? We will come back to this formula. Let's say I throw a die. Yes? So what are the possibilities? What's the set of possibilities? What's the sample space? This thing. Yes? 1, 2, 3, 4, 5, 6. Okay. So how do we assign probabilities? What is the process? What are the conditions? That we will see um, in detail later. So um, let's play a game quickly. There is a bag. Let's say I have a bag. There is only one ball in there, yellow. Okay. You have to close your eyes, put your hand in the bag, take out exactly one ball. This is the setup. In probability theory, or we call this the experiment. So you always have to define the setup or the experiment. Yes, what is the experiment? It is a bag. It has a yellow ball inside. You have to put your hand in, take out exactly one ball, and of course without looking. Yeah. So in this case, what's the probability that you get a yellow ball? 1. Yes. Why is that?
There's only one ball.
Intuitively, that's what you did. But what if I say you actually use this formula without knowing it? Did you use this formula? Okay. What's the experiment I described? What's the A is the event that you want to see. Yeah? So let's see that. The universal set is yellow. Event is that the ball drawn is yellow. The universal set is also this one, yellow. Probability that A happens, that is, this event takes place, that is, that you get a yellow ball, is 1. Why? Because you said, okay, number of ways A can occur. Basically, since there is only one ball in there, nothing else can happen. You can only take out the yellow ball. What were the total outcomes? This total possibilities, only the yellow ball in there. Okay, make it a bit more interesting. Yeah? What's the possibility now?
1 by 2.
1 by 2. Yes? Intuitively, you can tell that. But what have you done now? Again, intuitively you have applied the formula. Why is that?
You just have to take out one ball and the total
number of ways a yellow ball can come out is 1 chance. Yes? And the total possibilities are now 2. You could have taken out a yellow or a red ball. So there is 1 in the numerator and 2 in the denominator. Right? So it's a 50% chance that you get the red ball. But what I want you to see here also is this structure. How do we assign probabilities again? How do we assign them? It's a 5-step process. You define the experiment, you define your event. Event is the thing you want to see, the outcome you want to observe or talk about. You define the universal set or the sample space. Yes? And then you apply this formulation to that. In these easy cases, you didn't have to do that. Intuitively, you told me the answer. But as things get more complicated, this will get more interesting. So, just to make it more interesting, you can define an event which is impossible. Yeah. So, in this case, what's the probability that I draw a white ball? 0. Number of ways you can draw a white ball is 0. There is no white ball. So out of 2, 0 ways, so you get 0 possibility. Yes? So universal set, of course. This is interesting also. What is the possibility that the ball you draw is yellow or red? It's 1. It's 1. Why? Now you have your set, your possibilities. Either you draw yellow, you cover this. Yes. If you draw red, you still cover this event. So you have 2 ways, and the total possibilities are also 2. So you get this thing. Same thing you can try to repeat for a dice. What's the experiment here? Experiment is you throw a fair dice. Fair dice means it has 1, 2, 3, 4, 5, 6 written on it, and it's not rigged in the material. Yeah. So event can be, it shows a 4. Experiment, throwing a die, a fair die. Event shows a 4. What's the universal set now? See, the universal set for you will depend on the what?
Outcome.
experiment.
Then
पहला experiment ball draw करने का, उसका अपना universal set, dice का अपना universal set, coin toss has its own universal set. What is that? H and T. Yes. So now, what's the probability that you? It shows 4 is 1 by 6. Yes, because out of the 6 members of the universal set, only one satisfies your requirement. Yes, so that is the universal set. Same here. So it's fair to say that this is what I am doing. I am applying what is the size of A divided by, sorry,
even numbers can do.
let's say the different event. Yes. Now you are saying, okay, what is the probability that you get 2, 4 or 6? What is the probability now? What is that? 50%. You are them even are these odd, so you already expect that. But notice what I am trying to show you here very quickly is that what you are applying is this. You are saying size of the set. Remember when I said probability and set go together? Yeah. You define your set A, you define your universal set, and the probability is size of set A divided by size of the universal set. This is what you have been doing. Yeah. So, of course, the probability series 1, 6 by 6 is here. So that is. To answer this question, how do we assign probabilities? It's a 5-step process. What's the first step? Define your experiment. Okay. Second step, define all the possible outcomes of that experiment. Yes. For rolling a die, the possible outcomes are these. For tossing a coin, possible outcomes are 1, 2, 3, 4, high or tail. For the height of the next person coming in, height cannot be negative. We know that, right? And it cannot be, let's say, 20 meters or something. So you take away the impossibility that if you have never seen that height. So you define the universal set. Third step, define the outcome that you would like to see. Like you said, what's the probability that we draw a yellow ball from the line, right? That's your event. Experiment, universal set, event. Step 4, assign the probability. One way is to do it like this. Okay, this is the most common way and this is the only way you cover this course. But there is another way, Bayesian approach. We will not go to that. That is a belief-based or priori info-based approach. But here, you will apply this thing. Number of ways your event of interest can enter divided by the total number of items. Fifth one, that I didn't cover yet, right? And I will not cover it now. I will come back to this one next time. What is it saying? This one? The assigned probability should make sense. Now, how does a probability make sense? That we will discuss next time. कोई है guest है अब कोई नहीं? So इससे सोचना in all these cases we assign probabilities, yes, but we didn't check do they make sense. Next time we will see what does that mean for a probability to make sense. Any questions so far? No?